everyone, welcome back to the new school year and the second year of the BinarX Student Payload Development Program. Thank you all for your amazing effort, your teachers and yourselves, all the work you put into learning about space missions, electronics, payloads, and science communication last year. The whole team at the Binar Space Program and the Space Science and Technology Center at Curtin University are all super proud of you. At the end of 2024, thank you for coming and sharing your preliminary design review presentations and some prototypes with us at Curtin. Today, we're going to go over what the plan is for 2025 and the key date for the second year of the BinarX Student Payload Development Program. You can see some of the photos from PDR Day there, the prototypes. It was great. We had our first space-ready payload handed over by John Curtin College of the Arts student Ben Hopper. So that's the first space-ready BinarX student payload that's been handed over, and we also made some updates to the ground station. So we'll talk about those now. But first, a few updates. We ran the BinarX Summer Holiday Program again in January of 2025, which is effectively the same sort of things that you all do in school. But we put it in rockets instead of satellites. So this year we were also supported by the Fogarty Foundation, as well as the WA Government Department of Jobs, Tourism, Science and Innovation, and the School of Earth and Planetary Sciences at Curtin. We had 18 students this year, so it was 17 students and one work experience student. And you can see in the photo there, one of the students launching his customized rocket with, I believe it had Dwayne "The Rock" Johnson's face on it. It was the rocket. So you can see just some more highlight photos there. We've got students building Lego and doing a communications exercise, having some fun, designing their circuits on paper before putting them on a breadboard. So remember that. So very similar to what you're going to do, just on a different looking board. And then some really amazing rockets designed by the students and hand painted by the students. So there were just a really great array of those. And then launch day. So just a whole lot of fun. And if you want to know more about it, just get in touch. But back to the important stuff for all of you. The plan for term 1 and 2, we'll start with 2025. So this is the overview. You're going to have the payload development kits and the boards. So that's this one right here, delivered by late March 2025. So right now you've got your prototypes pretty much done and your Arduino prototypes going. You're going to keep working on these until you're ready for a critical design review and test readiness review and payload handover day. So once you finish your Arduino prototypes, if it's already finished, you're going to start moving them over to the new STM32 and the breadboard, and then eventually solder them. The tentative day for your handover for your payloads is June 27th, 2025, and I'll talk more about that in a minute. And your launch date into space on the next Binar mission is planned for 2026. So that is really, really exciting. We are getting there. So let's break down the plan for term 1 and 2 here in a way that you can print out and sort of have handy or add it into your own project plans. The first half of this year is going to be a big push, and you may need to spend some extra time outside of your 1 hour a week class or club time. And it's also really important that if you feel stuck, you email binarx@curtin.edu.au. We are standing by and lots of engineers, lots of support ready to help you reach your goal of handing over a space-ready payload by June 27th. So we'll start with week 31, which is this week where you're listening. You're going to install STM32 Cube IDE, which is like Arduino IDE, but for the chip that you're going to send to space. It's a little more complicated. Don't worry, just get it installed now and create a MyST account. So you don't need to do anything with it other than get it installed and downloaded and create an account. So we're ready to go because you don't want to lose any time wrestling with software when you need it. You also need to check to make sure you have everything you need to put together your critical design review prototype. So is your Arduino-based prototype working? And have you checked the payload kits that you all have that you were given last year, those big 9-liter clear storage tubs? Is there anything missing from your sort of critical components list in terms of the sensors you want to use to send to space? If there's anything missing from the kit that you need to email us this week, like ASAP, or it might not, so we can get a new one for you, or if it's broken, whatever, it might not come in time for you to build your final payload. So some people will need to divide and conquer. You'll have some people working on software, hardware, soldering this term, project planning, comms, etc. So Right now, you should be kind of here with your payloads. Just make sure depending on what sensors you're using, that you've got all of those. There's a bill of materials that you should have of what I have sent you. Make sure that's all there, and make sure if it's not there, let me know as soon as possible. So week 32 to 35, March 10th to March 31st, or the week starting, you're going to work on your final payload circuit design. So this is the one we're going to give you a digital template that you can design on and basically show where you're going to connect your wires and how that's all going to run. We'll send it to you. You can do it digitally. You can do it you print it out and do it by hand. This is the one from the school holiday program. It's going to look different. It's going to look like this board here instead of the rocket board, but you'll get that next week. So when you do get this, you're going to look at the silk screen on here, which is just the printing, and you're going to work out like you do with the Arduinos and where your sensors and everything goes, or power to your current pins in your prototypes. You're going to start working on translating that and getting that designed for the Binar Binar payload hat boards, which are going to go to space. All right, so yeah, those templates will get sent out to you next week. We'll be handing out the payload development kits and microcontroller boards. Those are the ones that we talk about in your guide to your BinarX payload. You should all have that PDF, either PDF copy or hard copy. Let me know if you don't have it. Those will come in late March, so you can start getting familiar with those as you'll be using them in term 2. This will all get you ready for your critical design review milestone. So that's week 36. It'll be in class. Either we'll come and see you in person, or we'll do it virtually, ideally face-to-face, but it will be at your school, not at Curtin. And then you have your term break in here, so the term 1 to term 2 break. So yes, for critical design review, you want to make sure that you've got everything you need for your payload. So all of the components, including resistors, capacitors, sensors, that you have on the design of the payload, and that you're effectively ready to start manufacturing the final one in term 2 after the school holidays. So in term 2, so let's see, we have term 1 here, term 2 here. You're going to take all of your components and your circuit design from term 1, and you're going to build it on a breadboard, just like this. Now this again is from the school holiday program, so that is the Rocket microcontroller board. You're going to use your BinarX payload microcontroller board. So don't worry right now, we'll go through it in more detail in future weeks. But yes, the week 37 till 40, you're going to be breadboarding your final prototype, sorry, not your final prototype, your final payload, and testing it by connecting it to the BinarX microcontroller board with some jumper wires. And you'll start working on your software in the new STM32Cube IDE software, which is what I'm asking you to install today or as soon as possible this week. So then weeks 41 to 45, this is the final big push to solder your components and mount any extra boards or support, especially for the camera payloads or anything that needs to point out into space. Not so much for our magnetometers or IMUs or things like that, but anything that needs optical payloads. You're going to solder those just like this onto your payload boards and mostly finish your software. And make sure it can communicate with the Binar flight computer. So this here is an emulator, or just basically we load the flight computer onto this board and it pretends to be our satellite, and you'll test it and make sure it communicates with those two things. And then week 46, which is a firm deadline, it's test readiness review day and payload handover day at Curtin. If you remember Ben Hopper from John Curtin, one of our pilot schools, he's here, he's handed over his space ready payload, which we then tested the hardware using our space environment testing facilities. So that's the thermal vacuum and the vibration. And then we also tested the software with our system. So payloads that aren't ready for handover and that don't pass testing by this day won't be eligible to go to space because we do need to start integrating them into our CubeSat. So we really need you guys to work, and we are here to support you to get you there. We have a lot of confidence in you doing it. You've learned so much, but just, please get in touch if you're struggling. So in terms of the software, because I'm told by my engineers that software is really, really the tricky part, you will have a little bit more time to tweak that in the first couple of weeks of term 3, but not for ages and ages, because once your payloads have been accepted and are inside our CubeSats, we can't change the software. So the slides will go on, and then that'll be that. But this, after you hand it over, doesn't mean there's nothing to do in term 3 and 4. You'll all be getting ground station and antenna kits for your schools so you can prepare to listen to and get data from your payloads when they go to space. So you're going to get to set up your own ground stations. And it's not just the Binar satellites you can listen to. You can listen to the International Space Station. You can use them for amateur radio. We'll talk more about this later. But for now, I want you to get stuck into it and building and get into the plan for term 1 and 2. It's going to be a big term. And like I said, you may need to work a little bit outside of your 1-hour sessions. Work as a team, share the load, share the work, divide and conquer, and email us at binarx@curtin.edu.au if you're stuck or you need anything at all. In 2026, good luck, everyone, and let's get you to space. We are so excited for how far you've come and what comes next. So next week, so for week 32, we're going to do that circuit design for your space-ready payloads on BinarX, where you'll start adapting your Arduino micro prototype circuit design for the BinarX hat boards. Not as hard as it sounds. You all have a really good understanding of pins, and they're named the same way, so it's just about changing from pins on the Arduino to pins on our hat board, which are then connected to the microcontrollers you're sending to space. So don't panic, we're here, and you don't even need us. I know you can do this, and you've got some really, really strong abilities that you've developed in the last year. And yeah, send through your questions. I know I've said this about 1 million times, but please send through your progress and questions to binarx@curtin.edu.au so we can support you. Thank you so much, and I'm looking forward to seeing all of you in person really soon. Bye.